I think we're live.
Just live on my screen, yes.
Cool. 0 viewers. That's good. Let's see if anyone joins.
What is it like being an MVP?
Pretty much like normal life, really. Not much change. I'd love to say that it's a whole different world, but it's not really. It gives you good access to things like the product team. You're on a mailing list for stuff. I'm an Azure MVP, so I'm on the Azure mailing list, so you can get good access to the product team and raise issues and talk about stuff. But it doesn't. That hasn't unlocked very many doors for me. I don't know. I think for me, it just empowered me and enabled me to feel enabled to go and do stuff. Gave me some confidence, I suppose. But it's a cool thing to have. But it's I don't.
How did you learn about Oleans?
So I was chatting to a friend of mine who works at Microsoft, and he'd got a copy of the code base a long time ago, and he kind of encouraged the team to look at distributing it and getting out there. And so then he gave me a copy of the code base. I played around with it, and then they launched the private preview program, so I got onto that, and then helped the guys with that preview to build some of the sample apps and wrote some of the documentation that came with the SDK, and that's that. We've got one viewer. Okay, shall I quickly start? I've got a couple of slides that I'd like to do, and then we'll turn it over to you. How did you do your desktop earlier?
On the left-hand side, there's a screenshot icon. Green screen with an arrow, second from the top.
Oh, got it. Yep. Entire screen. Okay. So what I'll do, open up Sublime Text. Yeah. Font larger. Control plus. Yeah. Okay. So, Orleans virtual meetup. Can you see my slide?
Yes.
Great.
Quick readable.
Very good. So, thank you everyone for joining joining the first meetup. Glad you can make it. We're recording this on video, so it should be available afterwards. So, why have I arranged this? Well, first of all, to get to know some of the people playing with or using Orleans, and to get to see the faces behind the Git commits and the tweets and everything else, and just to build some relationships, really. I also, whilst we've called this the Orleans virtual meetup, I don't want to really limit it to just talking about Orleans things. I think it would be interesting to talk about Akka or Erlang or other programming models and other ways of building distributed systems. So I don't want to only just talk about Orleans, but I'm happy to to be guided by people who join and see where the discussion takes us. I'd also like to kind of be inclusive and not be a clique. Anyone is invited to join. I'd like, anyone is welcome to speak, but I'd like to also keep the level of knowledge at quite a good depth. So I don't want to be doing introduction to stuff. I'd like to be exploring the nitty-gritty and talking about difficult problems and interesting stuff. So to share in-depth knowledge rather than superficial beginner stuff. We're recording it on YouTube, and we'll see where it takes us. Last slide. So I'd like to hear people's thoughts, and I'd like to be very much guided by what you'd like to do in future meetups. So first thing I'd like to hear about is leadership. I've set this up, but by no means am I some despot, tyrannical leader who's going to run the whole show. And it'd be great for. I don't really want to go and form a committee or have anything too formal, but it'd be nice if a few people could be involved, and I'd welcome other people helping to arrange it or coming up with ideas and taking a bit of ownership. So it's not just me, although I'm happy to carry on for as long as people attend. Times, I'm very aware that there is no time in the day that suits everyone, and I just arrange this for a time that's convenient for me, but I'm happy to perhaps shift this later in the day to catch some of the folks in the US, or earlier if people in Australia, it works better for them. I just thought there's quite a lot of Orleans stuff happening in Europe, so I wanted to go for a really convenient time for people in Europe, because I hear a lot more from Europe than I do in other parts of the world. Topics, again, interested to hear your thoughts on future topics, and Yevhen, if I've got his name correct, has offered to speak next time. We'll probably do one every month or something, so one in January, about design patterns with Orleans, which I think will be really interesting. And anyone else wants to speak, please get in touch, or use the thread, preferably in GitHub. So, without further ado, I'll stop sharing my screen and go back to Jacob, and I'll be quiet, and you can tell us about yourself, hopefully, and event-driven actor stuff with Orleans. Is that right?
Yes. So my name is Jakub. I'm a .NET developer, contractor. I mainly work in finance, but I've had a stab at creating a system for managing facilities. I've been using .NET Framework since the very first beta, so I would like to think I have a bit of experience there. And I recently have been quite interested in event sourcing, a slightly different approach to modeling and persisting your data. And with the actor framework, the one like Orleans, event sourcing plays really nice, and there's a lot of nice integration and cohesion there. So I thought I would give a quick talk about event sourcing and how one can benefit from it in an actor framework like Orleans. If you want to contact me, there's a Twitter handle and my email address on screen. If you need to ask some more questions after the presentation, just drop me a line, and I'll be happy to carry on the conversation. So what I would like to do today is introduce event sourcing, just to go through some basic ideas and concepts of event sourcing, and I'll actually explain how event sourcing and actors play together, because they do pretty nicely. I will show you how to implement event sourcing in Orleans, and that's based on my sample project, which is sitting on GitHub in Orleans contrib repo. After that, if you have any questions, there will be probably some time to go through that. So let's start with a quote from a Wikipedia, because a good presentation cannot have one. Object-oriented programming, as we were always told, integrates state and the behavior. So when you think about our objects, we see a class with a bunch of fields and properties which should be nicely encapsulated and internal to that class. And we have methods, code, behavior that modifies that state and performs some meaningful calculations. So the way we like to think about our code and the way we like to structure our code is the one where we design our class around the fields and the properties it will have. We like to see our objects being in a certain state, and then there will be methods that will be called when something happens in the outside world, and we mutate our state to now match whatever new has happened. So in terms of, for example, a purchase order, someone may register a new purchase order, then it gets approved, gets sent out, and is completed. And when we think about the life cycle of the purchase order, we see those four snapshots, four photographs of the purchase order in those four different states. Uh, and I don't think that this is necessarily the best approach, as because we will be mutating the state of our object, of our entity, and by doing that, we will be losing some data. We basically lose what was there in the past because all we have is the current state, the current values of all the fields and properties that define the state of our object. So what we usually end up with is the last picture in the series, the last snapshot, the last current state. But if we need to have the data from the previous states, we would try to sneak this information somehow into the current state. I'm pretty sure every one of us have seen tables or classes with columns and fields like created by, created date, modified by, modified date, previous status, current status. Those are, in my opinion, the signs of the problem that we are losing information, and then realizing that we're losing it, we're trying to somehow persist it and keep it, because it's not only the latest current state of the object that is interesting to us or to the users of our system, but they're also interested in the history of what has happened before. So the way we should be doing it, and that's what the whole event sourcing is about, is we shouldn't be losing our data. We should concentrate more on the transitions between the states rather than the states themselves. So every time something happens to our object, we should capture the fact that a certain event has happened. That event will cause the state of our object to change. That's perfectly fine, but we shouldn't throw away this quite valuable information that something has happened which caused our state to change. So instead of looking at our objects as the current snapshot of all the properties and fields that make the object up, we should try to see it as a timeline, as a series of events that led to the current state of this object. If we capture all the events that happened in the past, we have the full history of our object, and we can always go back and see what happened in the past, which will help us explain why our object is the state it currently is. Otherwise, it's quite difficult, and it is a bit of it needs a bit of detective work to try to figure out why my record currently has the values it has. It's because we've lost the whole history of all the transitions which led up to the current point. If you think about editing files, you may have a text file on your desktop, you open it, you edit it 5 times, you save it 5 times, that's the latest version. You open the file again, you don't know what was happening before. All you see is what's written in the file right now. That's why we love source control versioning systems so much, because they give us that history. Every commit contains the changes and we still can get the current version of the file, but we also have this whole rich history with all the changes that happened in the past. Uh, in the real world, we have things like passports, which basically are the very analog way of capturing events. Each stamp in your passport is an event that happened in the past, that contains a date, that contains some relevant information, maybe a signature, maybe some approval. And by looking at your passport, you don't see only the country you're currently in, you see your whole history of all your trips, and you can always recreate your journeys just by looking at the stamps in your passport. Another example is your medical history in your that sits with your GP or your family doctor. Every time you go to your doctor, every time you have a visit in a hospital, you have some medical tests done. All that information gets added to your folder, which gets bigger and bigger and bigger, and the doctor can always go through your history and see how you were feeling and how your body was functioning in the past. It's not just that he has one piece of sheet in the folder that says, "Oh, today you're healthy." We keep the history because it's very, very important and very valuable. The thing about history is that it happened and it really cannot change. Once something happened, once a certain event has happened, that's it. You can't deny it. If the parrot is dead, it will be dead. You can't do much about it. That's the fact. Not even a trip to Bolton can change it. And the fact that the history is immutable and that the events in the past are immutable gives huge, huge benefits if you think about storing them. First of all, because we want to persist all the events, uh, we know that we are not losing any data. That's the one of the most important benefits of event sourcing. If you have your database and you do an update or delete on any of your records, you've lost something. You won't be getting the data back. You may have a database backup, so you might restore your database and see what was there before, but that's not something you can easily do in your code programmatically to take advantage of. If you think about immutable events and if you think about how can you store them, it's pretty simple. You need an append-only storage because your events in the past do not change. You can't update them, you can't delete them, they won't be disappearing. You won't get new events in the past. Only new events can happen, and all you need to do is you just to append them to your storage. That means that the event storage system can be really, really performant because it has to be optimized for a simple case of I just want to keep adding something to my file. Append-only storage is very, very good for replication because you know that anything that has been written cannot change. Therefore, it's very easy to replicate. All you need to do is you need to know what is the latest event in your copy, and you just need to replicate whatever happened after that point in time. That means that event stored systems are really scalable because you can create a lot of copies of your history of all the events in the past, and then you can read them from any of the nodes because all those nodes will be identical. And because events cannot change, it's really easy to cache them. You can basically cache them for the infinite amount of time, and you'll be good because you don't have the biggest problem of caching, which is cache invalidation. You don't have the problem that the event will somehow change and mutate, and you may not have the latest version of that event. You may not have all the events, so you may be missing some events from the near past because you haven't replicated them, but all you have is 100% true. Your stream of events is a perfect audit. In many systems I've seen, there was always some kind of an audit table with a few string fields where we tried to store the audit information about what happened in the system. And the problem always was that how do we guess upfront what needs to be audited? Users will tell us that, oh yes, we want to audit those kind of events, we want to know when those things happen. But very often later on they come back and say, oh, we want to know about those events as well. And the problem is that because your code wasn't written, all the actions that happened in the past, they didn't generate those audit trail records. So now it's really, really difficult for you to back-populate your audit with the new requirements. Because we have the whole history, think about your history in Git, it's very easy to reconstruct historic state. All you need to do is you just replay events up to a certain point in time, and you look at how your object or how your file looks like at this point in time. It means that it's very easy to provide as-of functionality. Very often when we need to generate some extras from our systems, we need to generate them as of end of business day, as of a certain point in time. Usually this is achieved by, oh, we will run the query at that time, and what we will get back from the query will be more or less as of that point in time. But what if our system was down for an hour and now it's an hour later? How can we get the report as if it was executed an hour ago? With event sourcing, that's quite easy, because all you need to do is you just replay events as of the point in time you're interested in, and you don't replay the events that happened after that. It's also quite beneficial if you want to reproduce some production issues which are data related. Sometimes those bugs come to us and the code seems alright, but somehow something doesn't work and it's data related. But maybe the data that caused the problems has already been modified. So the only way to do that in the normal systems that we work on is to restore the database as of that point of time, and hopefully we can do that. And then let's hope that the data is correct and we will be able to reproduce the issue. With event sourcing, we can easily go back in time. We can rewind the events up to a certain point in time, so we can load our object in the state that it was precisely the moment the user performed some action which caused the problems. That helps a lot with producing the issues which are quite elusive and data related. Temporal queries are a huge thing in event sourcing. Because we have the whole history, we can start asking questions about what happened after something else has happened. Those are the questions which are very hard to ask in the using the regular storage techniques, because all we have is the latest state plus maybe some properties and fields which contain some historic data. But it's very hard to write temporal queries, and I believe even up to now the SQL hasn't been fully extended to support all the different temporal queries. Those queries can give really can bring a lot of benefit to the business, to the users, because they can start. We can basically answer questions which they really wanted to ask all this time, but we just weren't really prepared to answer them. Right now, your users are probably looking at a bunch of extracts generated at the end of the day, and they try to figure out what happened during the day, what are the changes between those two reports, and they are trying to reconstruct from those snapshots how the entities, how the objects have changed. With event sourcing, we can start writing temporal queries, which will give a lot of benefit to the users. One of the examples of those benefits are notifications. If you think about your Nest thermostat sending the temperature at your home to Google, you have this whole history of how the temperature changed over time, which means you can start implementing things like notifications when the current reading goes above or below a certain threshold, certain average. You can start using machine learning. You can feed those events into some artificial intelligence processes that will build some models using the historic data. They will learn over time how your system behaves, and you can use machine learning to answer some really interesting questions, just because you have the whole history. Uh, your immutable events are perfect for integration. If you need to integrate two systems, usually what we do is we have an end of day extract, and we try to import them overnight. And during the import, we need to compare what's in the new file with what we have in the database, and we're trying to figure out what are the actual differences, what has happened during the day, and how we should update our data based on the new extract. If only we could get all the events that happened during the day, then it would be extremely easy for us to update our system, because we know precisely what was happening. We don't get just the latest version. That means that integration is very easy. All we need to do is we can send those events, publish those events to any queue, and have some other systems just read them from the queue at their own leisure. They can do it. They can do it real time. They can wait for the queue to fill up and bulk import those messages overnight, for example. Uh, the thing is that we have not just the latest state, we have all the events, all the rich information about the data. We don't have just the data, but we also have the reason of why this data has changed, which helps a lot with system integration. And also event-based UIs. If you think about smartphone apps that are occasionally connected, you might want to sync with your server the events, the things that users have done in your app while the app was offline. If you just capture individual events, you can just send them back to the server, and the server can send back to you events that happened in the meantime. And it's quite straightforward to solve any integration problems, because you have a lot of rich information that describes each event, and you can make some conscious decision how you process events that happened while you were offline. And it's actually quite helpful and easy to implement event sourcing system, or to add features to event sourcing systems. First of all, you don't have to implement all the features today. You can implement your features in the past, in that sense that because you have all the data, you can write the code that will benefit from all the past data. Very often we were asked to add some new feature to our system, and we would deploy it to production. We'll tell the users, look, we've deployed the new version of the code. If you start using the system now, you will get the benefit of the code which I've just written. With event sourcing, we can rerun all our events using the new code, which means that we can implement the feature and give users the result of that feature as if this feature was implemented from day one, because we can run all the events through our new event handler, through our new projection, which means that if someone asks, for example, to find out and mark all the users as VIP users, clients who order more than for more than £1,000 per month. If you deploy that code to production today and you don't have that historic data, you can only start marking clients as VIP clients from that point forward. But if you have the history of all the events, you know how many orders your clients were doing in the past, you can go and retrospectively analyze those events and correctly mark all the customers as VIP based on the history of the sales. That means that event sourcing encourages you to use asynchronous programming or command query responsibility segregation patterns, because you want to be able to process your events in an asynchronous manner. You might want to add some new event handlers, to add some more projections which will analyze those events in an asynchronous way. That fits really nicely with distributed systems and queuing technologies. Basically, you just send those events to the new queue, and you have some new process that will go and analyze them. You haven't lost your events; they are all there. You just pass them to another queue, and you run some new code against them. That means that your system is more modular, and it's quite easy for you to add new functionality without affecting the rest of the system. When it comes to storing your events, they are usually stored as blobs. You can persist them as JSON and put them in any kind of storage that supports JSON. You can shove them into table storage. You can put them in a flat file. You can put them in a SQL database if you want. There are implementations for event storage using SQL databases. You can put them in a RavenDB. You can put them in the DocumentDB. It's really flexible, because at the end of the day, all you have is just a piece of string, and you can really store it in any key value store. You know that this event won't change. All you need to do is you just need to insert a new record. It's very easy to implement optimistic concurrency. Basically, the current version of your object is the number of events that have happened to that object. You can easily implement quite sophisticated optimistic concurrency clashes resolution. Usually, if we think about SQL databases, we would put a timestamp columns, and if two users are trying to update that record, and the first one will succeed, the second one will notice that the timestamp is different, and basically all can we do is we can just say no, you can't update, you have to try again. Because right now we are persisting our state by adding new events, we can analyze what is the actual difference between the version that I've loaded and the version which is right now in the in our event store, which I'm trying to update. If I'm trying to add an event called customer address changed, that may not necessarily clash with the event customer marked as VIP. That means that despite the fact that I have an optimistic concurrency issue, I may still resolve it myself, because I know that those two events are not updating the same fields. They are not affecting each other. and the address change and changing of the status of the client to VAP are not conflicting with each other. That can really help with creation of a really sophisticated ways to solve concurrency issues. Now, we said that the events are immutable, um, but sometimes you might want to correct the history. You may have some technical reasons to do that, and despite of the fact that when we talk about event sourcing, we try to emphasize the fact that the events cannot change. If we have to, we can change our history. We can rewrite it. One way of doing it is to migrate our event store to another instance. We may create a very simple console app that will be reading events from the left and writing them to the right and somehow manipulating them in the meantime. We actually can delete some events in the past if we want to. Just bear in mind that if you start deleting events, then you need to worry about your cache, because if there are some caches that cache those events, they will be out of date. So you're back to the problem of cache invalidation. Obviously, if you delete some events in the past, that means that your current status is different. Therefore, you need to recalculate your current state based on the remaining events. You can try to enrich events which were raised in the past. You may be storing some events and not storing all the data in that events which you store somewhere else. So it is possible to enrich the events in the past if you have some additional information stored somewhere else. You might want to split big events into smaller ones because, for example, you are capturing a lot of information in the event, and you might want to create a very specialized projections which wants to use only the subset of data. So there may be some technical reasons why you want to rewrite history, but you have to be really helpful because rewriting history is not a simple thing to do. The preferred way to cope with any problems with your events. So if you had a bug in your system and you were persisting data and you were doing something wrong, the correct way of do that is to add more events which will correct the state to be the desired one. Think about your bank account. If the bank credited your account in error, they are not going to remove that entry from the statement. They will add a new entry to the ledger to say, oh, we need to debit your account because it was credited in error. This is how we cope with errors in systems with immutable data. We add more corrective events to correct any mistakes that may have happened in the past. By doing that, you retain the full history and the full information that your system was in the wrong state for a period of time. That may help a lot to cope with any production issues or any user request, because you can clearly explain that, yes, last week we had a problem, that data was wrong, it was corrected last Monday, and now it's fine. You have the whole history of what happened, so you can easily answer the questions about the state of your system in the past. Now, how would we benefit from event sourcing in an actor framework like Orleans? It's very straightforward. Think about your actual state, and instead of seeing just the latest snapshot of the state, think about the history and all the transitions, all the diffs that happened in the past. Orleans separates the actor and the actual state, which means that it's very easy to implement the state using event sourcing apart from any other change you might want to do to your actor. Those two concepts of the actor and the business logic and the state are nicely separated of in Orleans. So every time we'll be thinking about event sourcing, concentrate on the actor state, not the actor itself. Now let's look at some code. If you have any questions, just interrupt me and ask. It will be just easier to point me at some piece of code and explain something to you straight away. So here is our grain. It's a standard Orleans grain that represents a person. We have a bunch of methods that will give us the first, last name, and the gender of the person. We can register a new person by giving its his names and gender, and we have the action of marrying a different person. So this is a standard Orleans grain, no different to what you've been seeing in all the code samples before. Now, when we think about the person and what can happen to it, we need to think about the events. So we may have the event of the person being registered. We may have the event of the person being married. And we may have the event of the last name of the person changing, for example, due to marrying some person and changing the surname, or maybe someone just decided to change the surname without marrying the person. Those events will contain all the data that we need to describe the event and also the surrounding environment. So, for example, the event that describes the marriage will contain the data about the spouse. We also have those apply methods in each event, which will be called by the framework, and they are used to actually mutate the state using the data from the event. So, for example, if the person last name changed event is raised, we have the new last name. We need to update the state of our actor to match what was what happened in the past, to match with the new last name. Now let's take a look at the grain itself. Let me change the font size. So we use the provider that will be using an event store to write and read the data from. We have a new base class, which I will show you in the moment, which deals with all the nitty-gritty details of persisting and applying events. And then we have our methods that we would usually have. So if we need to turn something from our state, we just access the state in the usual manner. However, when we want to update the state, we don't write to the state directly. We don't do this state.firstName equals. Instead, we raise the event. So this method is implemented in the base class, and it is a very simple method. All we do, we add the event to the list of events which haven't been persisted to the store. We apply this event to our state immediately. So after calling raise event method, your state will be updated. So you can do this state.firstName, and it will be the correct first name. And depending on whether we pass true or false as the second parameter, we write to the event store, or we just wait. This waiting bit allows us to implement transactions. We may raise multiple events in one method. It's not that every method should raise just one event. Our events can be as granular and as descriptive as we want them to be. So we may raise two events, and then we might want to persist them in one transaction at the end. If an exception happens between those two events, then none of them will be persisted, and our transaction will roll back. So let's write some code. Let's run some code and debug it, so you can see how it all actually works. I have a very simple script that let me zoom in a bit, that will create a person called John. So we have a new grain with the ID 1. We call a register method giving the first name, last name, and the gender. Then we will create Alice, and we will ask nicely Alice to marry John. As the event store, I'm using the get event store, which is a very nice system created by the company, founded by Greg Young. I will give you links at the end of the presentation. There are other ways to implement the actual persistent storage. There's a very nice library called N Event Store, which comes with a huge collection of different providers for storing events in table storage, in DocumentDB, in RavenDB, MongoDB, SQL, Oracle, you name it. If there is a database, there is probably a provider in an event store library that supports it. In those cases, because all we're doing is appending new events to the store, or just reading all the events from the store for a certain ID, the implementation is really easy, and the way you read and write events is quite similar to what I will show you in a moment. So let's put a few breakpoints and run it and see how it all works. So my silo is starting right now. So we create a new grain. Then we will be calling the register method. So if we jump in to the register method, here we are. We are, instead of updating the store the state directly, we will be raising a new event. So we will just add it to the list of the uncommitted events, and we will apply this event straight away, which means that our apply method here will be called, so we will update our state straight away. We increment the version on our entity. The base class from which our grain is inheriting inherits from the audience grain itself, and it has just our raise event method, which we are using in the individual grain, in the derived classes. So we apply our state, and then we want to store it. We will write it to the event store. The event store which I'm using comes with a simple user interface. So we have a website which shows us our grains. So we can see two grains created in here. Those are the streams. The name of the stream is the type of the grain plus the audience ID. So each actor has its own stream. And right now we can see a very simple JSON document which represents the event that we've persisted. Now we come to the marrying part. Let's go down to grain, and here we are. We will first raise the person merit event, passing the data that we need. Then we can implement whatever business logic we need, and we can raise one or more events if we want to. Those events are not persisted yet. If I look at the event store, they are not there yet. They are uncommitted, and as you can see, the state has been updated. The Alice's surname has changed into Doe. So now we can write the state, and if we look at our event store, we look at Alice, we will see that we've registered that person. She was then married to John Doe, and then her surname has changed. This stream of events is basically what event sourcing is all about. Keeping track of all the things that happened. So if you need, you can always go back in time, you can look at them, you can analyze them, you can process them in many different ways according to the new requirements that may come in the future. Let me just quickly stop and start again, and we will see what happens when we load an actor which has some state persisted. Let's quickly jump over here. We're not really interested in John because there's only one event for him. We'll go over here. And now let's look at the piece of code that actually implements the reading of events from the event store. This code is specific to the event store which I'm using, but all the other event stores will require a very similar code. So if we want to load an entity from the event stream, we have our grain and we have the empty state we need to populate. We first generate the stream name, that's the type and the audience ID. And all we need to do is we need to load all the events from the stream. Here we're doing it in the chunks of 500 events. We're loading it in pages. And for each event in the past that has happened, we will deserialize our JSON document. So here's our first event for Alice, and we use exactly the same. We call exactly the same apply method on the event to apply those data from that event to our state. So our grain state right now will be reflecting the state of our actor after the first event. If we carry on applying the events, we will see that the state will change with each event, and this is precisely the point where you can say, oh, I don't want to load all the events from the past, I only want to load events up to a certain point in time, and by doing that we will only mutate the state up to this point in time. That means that after we apply all our events, the state of the Alice will be as it was when we last persisted it. Oops. Namely, her surname will be Doe. Now you may be wondering, oh, we need to keep loading all those events every time, and there may be a huge number of events. we really don't want to be doing this over and over again because it may affect performance. And yes, that is a valid point, but in fact, it's not such a huge problem. First of all, our events are immutable and then can be easily cached. We are loading them from the store, which is optimized for loading events from the stream and giving them back to you as quickly as possible. So deserializing a complex object using the stream of events may be actually a bit faster than trying to run a SQL query with lots and lots of different joins to different tables, because our data is spread in multiple tables. There are also some other techniques which we can use to improve performance, and I will talk about them a bit later. So don't really think it's a huge problem that we are loading and applying all of those events. Usually when we think about our actors, we don't have that many events. I'm, for example, quite familiar with the trading domain, and we usually have lots and lots of trades, but not very many events for each trade. A trade may be an order may be booked, it will be filled in, it may be amended maybe a few times, it will settle. There may be a few other events, and we're really not seeing more than a dozen events for each trade. There will be a huge number of trades, but each trade will have only a small number of events. In real life scenarios, loading 500,000, 2,000 events from the event store is really a matter of milliseconds, and in the grand scheme of things is negligible. So our entity Alice was successfully loaded from our stream. We've loaded all the events. So right now our actor is in the correct state, and we can call some actions on it. So we have a bit more code in here. We create Bob, and we ask Alice to marry Bob, despite of the fact that she has already married John. So if we run that code, let me kill those breakpoints. We may end up in a very, very peculiar situation where something really wrong has happened to our system. Basically, we have a case of Alice marrying John, then marrying him again, and then marrying Bob. If we were to look at the latest state of our actor, we will see that Alice's surname is Hoskins, and if that was all that we had, it would be quite difficult for us to identify the problem of that there's either a bug in our code or the domain hasn't been properly modeled because we've forgotten to check if a person is married before we allow another marriage to happen. So what we can do is, because we have all the events, so if we try to load Alice again, we will be loading all of those events again. What we can do, we can try to, for example, figure out if the person is married. We can extend our state with a new Boolean property. For example, is married, and we may, for example, add another property called is married twice. What we need to do is we need to just apply change our apply methods for our events to now set the values of our new state properties accordingly. So if we look at um, the person merit event, what we will do is every time a person is married, we want to change our state like that. And if our person was married before, so if state is married, and we're trying to marry again, we just said is married twice, two.
Hey, Jacob,
Yes.
we've reached the end of our time, so some people
Mhm.
may need to go. I just wondered if
Okay,
anyone
let
wanted
me
to ask any questions before everyone had to go, or if there's any questions now, feel free to type in or join in the audio if you can.
let me wrap it up all very quickly.
Cool.
Uh, the performance issue, which I've mentioned before, that's already solved nicely by Orleans, because Orleans keeps actors in memory for you. So you don't have to keep loading all the events every time you want to call an action on the you want to send a message to your grain, because the grain will probably be there in the memory, and it's only when you actually need to load the actor in the memory, then you need to load all the events. There's also the concept of snapshots. So if you really have a huge number of events, you might want to persist your state into the storage after a number of events. So then, when you want to read your event stream and deserialize the state, you start by loading your persisted snapshot, and then only applying the events that happened after that snapshot was persisted. Uh, that's a well-known technique in event sourcing, but one that one has very rarely to use. My experience with event sourcing was that there's a bit of a learning curve, because you have to make this mental flip of remembering that you have all those events in the stream, but at the end you actually save quite a lot of time, and you can better model your domain. And knowing that you have this huge store full of everything that has happened gives you a benefit of safety, because no matter what you do, you know you can always go back and you can always correct things. It's not the case of, oh, I've run my update statement or I've run my delete statement and I've lost something and I can't get it back. Here's the list of the resources for reading and for writing, which I can recommend. And if you have any questions, just fire them off.
I think Ruben had a question, which is, are you using it in production anywhere?
Uh, I am using event sourcing in production for a couple of systems. I'm actually using the N event store library with SQL persistence. That's because the client I'm working for insists of using SQL Server, and this has really helped me a lot with solving production issues, and it gives me a lot of confidence with, as I've said, with the ability to look at the whole history of the stream, and being able to correct events in the past, or rebuild my projections, or enrich my projections based on new requirements. So I have a couple of systems which are not using Orleans. Those are the more standard ASP.NET MVC application with some Windows services, or for running some background processes. But we are using event sourcing as the persistence model, and it was actually quite beneficial. And I must say that other developers for whom the event sourcing was quite new literally after debugging through the code a couple of times, they picked up the idea really, really quickly, and it wasn't at all a problem for them to start adding more features and extending those systems.
Looks really cool. I think, unless there's any other questions, has anyone got anything else they'd like to ask or say, or anything as a kind of wider discussion? We've been having a little chat in what is it called? Jabber while you've been talking, and I think Ruben has got some interesting things we'd like to talk about, but I think Yevon, if that's the right way to say your name, I think we'd like you to,
Yeah, that's right.
to speak next, if that's possible, at the next meetup.
Yeah, the next meetup I was speaking about the Arlene's Bus project. It's CQRS-like messaging communication style architecture that is built on top of Arlene's, and if you combine it with the event sourcing that the Jakub just told us about, it will be very powerful combo. So next time.
That would be cool. We'll have to pick a date for that. So if you could let me know a day and a time that works well for you, I'll set it up.
Yeah, cool.
Anyone else? Silence. If you could tweet out the links and stuff at the end, Jacob, that'd be really appreciated. And on behalf of everyone else.
Yes, I will put it online and send a tweet with the links. If anyone wants to come back to me with some more questions, I'm more than happy. Yeah, I'll hope to see you guys next month.
Cool.
When it comes to the date and time, I don't know if you are all based in Europe, but for me, anything in UK time zone is fine.
We've got a couple of Aussies on the call. I don't know what time it is in Australia, about midnight, I expect.
So maybe we want to move it a bit earlier.
Yeah, midnight. I think if it's a bit later, we can catch America. So I don't know. It's not it's not an easy thing to answer, but let me know in the forum in GitHub afterwards, and we'll pick a time that works. Cool. Thanks for joining, everyone. Good to see you, and we'll do this again in a month's time.
Yeah, see you.
Have a good day, guys.
Thanks. Bye-bye.
Bye, everyone.